Okay, so we're going to just practice plugging in systems, getting answers from our calculator. This first one we'll be doing A, B, and C, which is an example of each type. There's going to be a one solution case, a no solution case, and then the infinitely many case. Alright, so the first one, part A. So again, there's my system. Now you may need a little bit more room than I gave you there on the notes. You might need to do this on scratch paper or side paper, notebook paper. First thing is this isn't standard form. Right, the first equation is I've got x, y, z equal my constant. The last one's fine. I've got x, I've got z. There's no y, but I'll just put a 0 there for y. This one I need to move the y over, so I'll have to subtract y from both sides, and so I'm going to get negative y plus 2z equals 5, and now it's ready to go. And so my augmented matrix, which is going to be a 3 by 4, my first row goes with this equation, so 1, 1, negative 1, 2. My second row goes without. There's no x value, and so if you want to think about it, there's a 0x there. And so you put a 0 in the x spot. Negative 1y, 2z, 5 for the constant. And same thing here, there's no y, so we put a 0 in the y spot. So 1 for x, 0 for y, 1 for z, and then negative 1. There's your matrix A that you would type into your calculator. You do your RREF, row reduced echelon form, and you get, when you do that, 1, 0, 0, 0, 1, negative 2, 0, 0, 0, 0, 1. And so remember what this means. These are my x values, y values, z values equals my constant. And so if I go down here, and remember, there's that equal sign between the last row and my variable rows, or my last column, not row, my last column and my variable columns. This last row is telling me 0 equals 1. All right, well, I know that's false. 0 doesn't equal 1. And so this is the no solution case. Actually, with the 3 variable sets, you tend to get no solution cases as often as you get one solution cases, because it's a little hard to match up 3 equations than it is 2 equations. Alright, so no solution case is a little more often, meaning all 3 lines don't necessarily meet at the same point. Right? They could meet at different points, not meet at all, and be parallel. It doesn't necessarily mean parallel. It means you can have one line meeting at one point and another line meeting at another point, and they cross and intersect at the wrong points. You got more options here for no solution. Alright, so problem A would be no solution. Wherever you see this, it's a false statement and it's the no solution case. Alright, B. Alright, all of them are in standard form, so I don't have to worry about standard form. I do need a 0 here for the y in the second term. So my augmented matrix that you're going to plug into the calculator is a 3 by 4. So this is going to be my matrix A. First row, 1, 2, negative 3, 5. Second row, 1, 0 for y, 1 for z, negative 1, 2, 2, negative 1, 4. We do our RREF, row reduced echelon form, and we get across the top 1, 0, 0, negative 1, negative, or 0, 1, 0, 3, 0, 0, 1, 0. Alright, so this is our nice case. This is our, whenever we get this out, that's our row reduced echelon form where there's 1x, 1y, and 1z equals whatever those constants are. This is our one solution case, right? The first row gives me my x equals negative 1, the second row gives me my y equals 3, and the third row gives me z equals 0. And so we have one solution. There's one solution. It's the point negative 1, 3, 0. Negative 1, 3, 0 solves my system. If I plug those numbers into these equations, they all are true, which means those 3 equations all intersect at that one moment. Right, which means by processes of elimination, the next one's going to be my infinitely many case. Alright, problem part C. So my 3 variable setup where I get my, so I already know this is going to come out in the infinitely many because I did one of each type. So it's actually not that much different than the last one. Actually, I think the only differences might be this 2. So when you go type it in, I think that's the only thing you'll have to change from the previous one that we did. just retype it in to be on the safe side. All right, but there's my 3 by 4. All right, make sure I double check, make sure I wrote that out right. 1, 2, negative 3, 5. No, I didn't give you enough room to do this one. So, again, you might want another sheet of paper out to write this all out on. Alright, so, I know it's going to come out, and so what the calculator gives me when I have 3 variables, and it's the infinitely many case. 1, 0, 2, negative 1. 0, 1, negative 2 and a half, 3. Move that over. 0, 0, 0, 0. Alright, so remember, this is my x, this is my y, z equals my constant. The last row is just telling me 0 equals 0, which is true. Alright, which means my row 1 and my row 2 are true, but they're equations. I don't get just x, I've got an x and a z. If you look, see, I've got one x, no y's, but I've got a 2z and a constant. And the second one, I've got no x, I've got one y, I've got negative 2.5 z's and a constant. And so what we do is, this is just telling me it's true, meaning none of my equations are false. So it's all true, right? All of my equations are true. And since I have equations where I don't have one x, one y, and one z, and it's true, it's not a false statement, well, what's left for me then is the infinitely many case. So this means it's the infinitely many case, which is the hard case. I have to come up with a solution, a system, an equation, where all I have to do is pick an x value, a y value, or a z value, and I've got an answer. Now, due to the nature of the Gauss-Jordan, there is always one way that's usually the easiest to go. If I write down my row 1, my row 2 in this row reduced echelon form, right? My row 1 is x, no y, 2z equals the constant negative 1. My row 2 would be no x, but there's one y, negative 2.5z equals the constant 3. If you notice, those two equations, which are true, right, it means they're linear lines that I could draw, they're true, there's infinitely many solutions on both of them. What do both equations have in common? Well, they both have the z term. If I pick z to be my arbitrary variable, I can find x and I can find y. And again, that's what happens with how the program works. It's always going to eliminate the z variable because of how and it's always going to leave you with one x and one y, because that's how it works. And so we're going to let z be the arbitrary variable. Which means I'm going to solve for x and I'm going to solve for y, which again isn't too hard to do using those two equations. If I solve for x in that first one, all I have to do is subtract 2z from both sides. And so I get x equals negative 2z minus 1. I do the same thing for y. I move the z over. This time I'm going to add 2.5z to the other side. And so my y is equal to 2.5z plus 3. And so I know what my x is if I pick z, and I can find my y if I pick z. And so the solution is the point, the ordered triple, where x has to be negative 2 times z minus 1, y has to be 2.5z plus 3, and then z gets to be whatever the heck z wants to be. Z is the arbitrary variable, and so it's the one I get to choose, right? Z is arbitrary, which means it can be anything I want it to be. I can pick z, and I have a solution. All right, so, I mean, I'm just going to do an example. Suppose I pick 1, right? So I pick z equals 1. Well, if z equals 1, then the x value, I'll plug it in here. I get negative 2 times 1 minus 1 is negative 3. The y value is 2.5 plus 3, so that comes out 5.5. And so a solution is negative 3, 5.5, and 1. That's one solution. There's infinitely many because there's infinitely many values I can choose for z. Alright, that's 1. I could do zeros pretty easy. If I do z equals 0, I get x equals negative 1, y equals 3, and so there's another solution. Negative 1, 3, 0. Alright, so again, remember the arbitrary case, this is the solution, allows me to pick any real number value from infinity to negative infinity, and there's infinitely many values I could pick, because there's infinitely many solutions, and solutions have to follow that group, right? This z that I pick has to be paired with that specific y value and that specific z value given in those formulas. And again, due to the nature of how it works, it's always going to be the easiest to set it to z, and we're going to practice this in the next video.